Welcome back to our continuing series on becoming an evidence-based analyst. In this installment, we will continue our review of how to evaluate evidence. You will learn how to use reliability analysis to extend a designative model with factors that may be advocated as recommended solutions to a problem. As with each tutorial in this series, we will first quickly review the steps of EBA. A review of the steps will ensure that you are clear where this tutorial fits within the overall process of evidence-based analysis. The remainder of the tutorial will be a step-by-step guide to developing and evaluating an advocative claim. As we progress through each step, you are encouraged to frequently pause this tutorial to practice the step on your own. To maximize the benefit of practice, apply the procedure to a question that you are currently researching. The insights gained will expand your distinctive expertise by suggesting what factors can be assessed and/or manipulated to create an effective intervention. As discussed in the previous tutorials, there are 4 steps required to perform EBA. These steps allow us to develop a recommended solution to an important problem. We begin an evidence-based analysis by asking an answerable question. In the second step, we seek to find or develop a model of the causal factors and their effects. In step 3, we evaluate, compare, and systematically analyze the substantive effects across a variety of settings. The evaluation begins with rating the quality of evidence. A previous tutorial provided a step-by-step method for rating evidence quality. Once we have verified the quality rating, we examine the findings presented in the study. Evaluating the evidence presented in a study requires analyzing the effect sizes that are reported in tables or diagrams. In part 2 of the tutorial on evaluating evidence, we reviewed how to analyze meta-analysis tables. Meta-analysis is the highest quality of evidence that is used to evaluate designative warrants, or the path models that predict the effect of causal factors on outcomes. In this tutorial, we will move to the left of the causal factor to examine the intervention factors that can reliably indicate change in the causal factors. A recommended solution advocates assessing and/or changing these intervention factors to bring about effective change in the desired outcomes. Finally, in step 4, we will assess the risk of this recommendation by calculating prediction and measurement risk. For this tutorial, we will continue with our investigation of the claim statement. An effective working relationship with your boss predicts all of the outcomes of organizational behavior. In other words, the exchange between a leader and a member of the organization is predicted to be a highly substantive influence on the desired organizational outcomes. This slide shows the final model produced in the Step 2, Part 2 tutorial. In Step 2, we examined 5 warrant models of the antecedents or causal factors and their consequences or effects of leader-member exchange, or LMX for short. This model predicted that transformational leadership will have a large effect on LMX. LMX was also predicted to consistently have a moderate effect on organizational commitment. LMX was predicted to have less consistent effect on citizenship behavior and performance. In Step 3, we will be examining and evaluating additional evidence for these effects. In this tutorial, we will first convert this complex model into a simplified direct effects model that is focused on the factors relevant for our research question. Next, we will develop an advocative claim model. This model will warrant a solution recommendation by identifying intervention factors that can reliably indicate change in leader-member exchange. After the conclusion of the tutorial, you will be asked to apply these techniques to develop an EBA presentation to assess a claim that you are investigating. To develop an evidence-based advocative claim, we begin by simplifying the path model that warranted the designative claim. There are 4 steps to reducing a complex designative claim model, such as shown here, into a simple model. First, we calculate all of the substantive direct effects. This often requires that we apply Wright's path tracing rule calculations that were discussed in a previous tutorial in this series. Second, we prepare a direct effects model diagram showing only the total effects of each causal factor. Third, We classify these effects into small, medium, and large effects. Finally, in the fourth step, we reduce the model to the highest classification. In summary, we simplify the model to focus on the designating factors that have the largest impact. In step 1, we start by identifying the simplest effects. This means that we begin by identifying the factors that have only one estimated effect size and is only directly connected to an outcome. In this diagram, we would make a note that organizational commitment has a negative 0.36 effect on turnover intention. We then move to any factor that has only a direct effect, but where our prior analysis has produced a range of correlation estimates. When a range of effects have been identified, we must calculate an average of effects. If we had identified the quality rating of each of the studies providing the effects, we would also weight the correlation by factoring in the quality rating of the study, the size of the sample, and other factors that would impact the relative importance of the study producing the estimates. The weighting method will be covered in a future tutorial. For now, to determine the mean weighting total effect for organizational citizenship behavior, OCB, we would need to calculate the average of 0.51 and 0.77. As shown in the table on the right, this average is 0.64. We continue our calculations by moving to those factors having both direct and indirect relationships with the outcomes. The two tables shown on this slide apply Wright's path tracing rule calculations to determine the total effect of leader-member exchange, or LMX, on turnover intention and job performance. Finally, to finish step 1, we calculate the total effects of any factors that have only indirect effects on the outcomes. In this case, there is only one of these factors, transformational leadership. Since we already calculated the total effect of LMX on turnover intention and OCB, we can simply multiply the effect of transformational leadership on LMX by the LMX total effect on these two outcomes. The table on the left shows the calculation and the resulting total effect of transformational leadership on the outcomes. This would be an excellent point to pause the tutorial playback to practice this first step on a warrant model of a designative claim that you are analyzing. I will pause briefly now to allow you time to pause the playback before moving on to step 2. In step 2, we redraw the designative claim model with only direct connections between each causal factor and the outcome factors. If more than one factor affects multiple outcomes, as shown here, it is advisable to first draw the larger effects first and then add the smaller effects nested inside them. A nested effect indicates that the factor to the left is more effective as an influence on the outcomes than the factor nested within it. This is another way of interpreting a mediated relationship. In the original model, LMX fully mediated the effects of transformational leadership on the outcomes. Therefore, a solution would be more effective by improving LMX than it would be by instituting or increasing the level of transformational leadership. You may wish to pause the tutorial playback to practice this second step. I will pause briefly to allow you time to pause the playback before moving on to step 3. In step 3, we classify the effect sizes into small, medium, and large effects. Small effects have correlations between 0.3 and 0.49. Medium effects are between 0.5 and 0.7. Large effects are 0.7 or higher. To create a direct effects model in the final step, we will eliminate all but the highest effect size classification. We will also eliminate any effects that were not related to our research question. In this case, we will eliminate the effects of organizational commitment and OCB since our question was focused on LMX. We will also eliminate transformational leadership since it had a small effect on the outcomes. If our question had been focused on the outcomes rather than the causal factor of LMX, we would have kept the path from OCB to job performance, but eliminated organizational commitment. As shown here, organizational commitment had a small effect on turnover intention and therefore should be eliminated. You may wish to pause the tutorial playback to practice this third step. I will pause briefly to allow you time to pause the playback before moving on to step 4. This slide shows the final direct effects model that will guide our development of an advocative claim. You may wish to pause the tutorial playback to practice this fourth step. I will pause briefly to allow you time to pause the playback before moving on to discuss how to search for advocative claim intervention factors. The search for advocative claim interventions uses the keywords scale and validation in the search string. These are followed by the causal factor that we wish to influence. You can also add keywords associated with intervention factors that you believe from your readings may be influential. In the area of organizational behavior, individual behaviors such as LMX are often influenced by individual level cognitive factors such as decision-making, motivation, learning, punishment, and rewards. These individual factors are, in turn, influenced by group-level factors such as group process and interpersonal conflict and communication. Finally, these group-level factors are influenced by organizational-level factors such as organizational culture and change processes. Therefore, depending on your level of analysis, you should include factors at the next higher level in your search string. For our example of LMX, we could search scale validation, leader-member exchange, in quotes, and job characteristics. Instead of searching, we could have looked at the referenced articles that provided the comparisons in the designative claim model. These would be found in your PICO summary. These articles would likely provide the scale factors that will become the basis of an advocative claim. In this tutorial, we will focus on the Google Scholar search method. The top results of this search are shown on the right side of the slide. The first article seems to provide exactly what we need to develop an advocative claim because it validated the leader-member exchange scale. The word multidimensional in the title indicates that this paper will provide us with multiple factors that could be used to assess or develop an intervention to impact the amount of leader-member exchange occurring in an organization. A unidimensional scale would provide factors for an advocative claim, but the definitive claim would be much weaker. A unidimensional scale has only one measure for each factor. A multidimensional scale provides a more robust advocative claim because we will have multiple statements or questions that will provide insights into what must be done to influence the causal factor, LMX in this case. The diagram on this slide shows the 4 factors that Blyden and Maslin found to be involved in bringing about leader-member exchange. Notice how the arrows point to the left and to boxes instead of ovals. This form of diagram informs you that this is an advocative claim rather than a designative claim. The claim is that affect, loyalty, contribution, and professional respect are the 4 factors which intervene to bring about improved leader-member exchange. The definition of these 4 factors is provided by the statements or questions that are indicated by the boxes. These are the measurement items for each advocative intervention factor. The reliability of these indicators is provided by the factor loading coefficients shown on the lines between the ovals and the boxes. The overlapping arrows on the right side of the diagram can be ignored for our purposes. These provide estimates of the degree to which each of the intervening factors actually affect each other. More advanced evidence-based analysis would consider these intercorrelations when identifying which of the 4 factors might be the best to focus on during an intervention. However, we will ignore these lines for our analysis. Finally, each of the subscales represented by the 4 factors will have a reliability estimate, or Cronbach alpha coefficient. We can find these reliability estimates by searching the paper for the words alpha, Cronbach, or reliability. Sometimes they are shown with the Greek letter alpha, but most often in a sentence that describes the measurement items. The paragraph excerpt at the top right of the slide was found in the results section of the Leiden and Maslin 1998 paper. They report reliabilities for different groups. For our analysis, we will use the student results. You may recall from the prior tutorials that an evidence-based analyst only recommends solutions that have substantive reliability. We define substantive reliability as alpha coefficients of 0.7 or higher. Consequently, the factor contribution is not substantive. If we find that the contribution factor is substantive in future studies, we would want to note that there is insubstantial effect size risk. There is insubstantial effect size risk because this study's results indicated that for both students and employees, contribution was not a reliable indicator of LMX. Based on the Leiden-Maslin 1998 results, we can now prepare an advocative claim warrant model diagram. The diagram shown here includes a dashed line for the link between LMX and contribution to signify that this effect was not substantive and should be considered with caution. How reserved we should be in advocating for increased contribution will be determined by examining further evidence that applied this scale to assess the level of LMX in organizations. We are now ready to search for evidence that can be used to evaluate both the advocative and designative claims. We have covered evidence evaluation for designative claims in the meta-analysis tutorial that preceded this one. Here, we will focus on searching for evidence that evaluates an advocative claim. To conduct an advocative claim evidence search, we select the Cited By link in Google Scholar for the paper that provided the advocative claim, Leiden and Maslin 1998 in this case, as shown at the top of the results page. We click the Search Within Citing Articles box. Then we enter a search that includes the evidence quality we seek, such as meta-analysis, and the substantive intervention factors included in the advocative claim. In our case, we search for meta-analysis, performance, effect, loyalty, professional respect. The top results of this search are shown on the right side of the slide. You should always examine the titles of the articles to attempt to locate one that relates to one or more outcomes in your advocative claim model. Here we see the second article includes an analysis of the follower's performance. We would select this article for further analysis. After opening the article, we would search within the text for words alpha, Cronbach, or reliability. The text on the right was excerpted from the article. You can see here that the study by Wang et al. 2005 found that affect was substantively reliable, though at 0.82 it is less reliable than the 0.90 estimate by Leiden and Maslin 1998. Similarly, professional respect was found to be substantively reliable, though less so than originally estimated. Finally, loyalty was found not to be substantively reliable, though contribution was. Therefore, based on the combined results of Leiden and Maslin and Wang et al., we can conclude that both loyalty and contribution have insubstantial effect size risk. We would next classify the reliabilities of the two consistently substantive intervention factors. The advocative model diagram is shown on the bottom right to facilitate this analysis. Affect reliability ranges from 0.82 to 0.90. Professional respect reliability ranges from 0.86 to 0.92. Averaging these effects produces a mean reliability estimate of 0.86 for affect and 0.89 for professional respect. We can conclude that both of these intervention factors have moderate reliability. Now it's your turn. You should practice applying the evidence evaluation process that we have reviewed in this tutorial. First, identify one or more causal or outcome factors that you find personally interesting or which you believe will be important to your future career. Determine if a designative claim has been proposed regarding the factors. If so, then locate a model that explains and predicts how the causal factors should impact the desired outcomes, as we did in the previous tutorials. Next, convert a designative model into a direct effects model before developing an advocative claim using the procedure described in this tutorial. Search for evidence related to the factors in the advocative claim model that includes all intervention factors proposed as a recommended solution to enhancing the desired levels of the outcomes. Revise the model diagram based on your findings by replacing the estimated effects with correlation ranges derived from either multiple studies or the confidence intervals from a meta-analysis. Conclude your analysis by documenting the insights gained from this analysis and whether the evidence supports or poses reservations for your advocative claim.